Still too young to fail.
Hi everyone, welcome to the source tutoring. In this video I'll be doing the operator, and that was an introduction by Angus and Julia Stone with chocolate and cigarettes. I like that part, too young to fail. Okay, so this question is from a question paper of 2014, May 2014. I'm not sure which question it is, but just go through the question paper and then check it out and possibly try to do it and then come back to this video. Okay, so we are asked to determine the general solution. But asked to determine the general solution of the operator here, and then that means we'll have to determine the complementary solution and the particular solution. Yeah, this is what we actually have to determine, and then just add them together, because you know that y, the general solution, is given by yc plus yp. So we need to determine yc and yp. Okay, I'm gonna first determine yc. So with yc, we know that the right hand side must be equal to 0. So we're gonna write out the operator as d squared minus 2d plus 5 operating on yc. Now complementary solution is given by is equal to 0. Okay, so we're gonna you can use whichever method you use to solve quadratic equations, but you can use quadratic formula because it's fast, and yeah, because it's fast. So you see, when we use our quadratic formula, we're gonna get d is equals to, where this will be our coefficient of d will be 1, coefficient of d squared will be 1, coefficient of d will be minus 2, and then our constant is 5. So using quadratic formula, we're gonna get 2 plus or minus the square root of 4 minus 20, okay, divided by 2. Okay, so we find that d is equals to 1 plus 2i, or 1 minus 2i. Okay, so that means we can write the factorization of this thing here as d minus 1 d minus 1 plus 2i multiplied by d minus 1 minus 2i. Okay, minus 2i, y is equal to 0. Okay, now our complementary solution yc is given by e to the power of the real part of the solution, and that real part is minus 1. So when it gets here, it becomes positive 1. So we erase it and multiply by t into a constant p cos of the imaginary part. Our imaginary part here is 2, multiply that by t, and then plus q sine of 2t. Okay, so this is our complementary solution for this d operator here. Okay, now we're gonna have to determine again the particular solution, okay, which is very long, and I think most of the marks on this question come from determining a particular solution. Okay, now let me just copy down the question. So we want to determine the particular solution of d squared minus 2d plus 5 operating on y is equals to t cos t. Okay, And now, okay, we know that the particular solution yp is given by t cos of t divided by d squared minus 2d plus 5. Okay, now note that cos t is the real part of e to the it. So we say that, okay, cos t. Okay, this equation tells you that cos t is the real part of e to the it. So I'm gonna replace cos t here by this thing here. Okay, so yp is equals to t, the real part of e to the it. Okay, and that is divided by d squared minus 2d plus 5. We're gonna then apply the shift lemma, which tells us that we take this real representation here and then we substitute d by d plus I. Okay, so we're gonna have the real part of e to the it divided by d plus I squared minus 2d minus 2I plus 5 operating on t. Okay, now we have this thing here. Okay, so let us work out the denominator of this thing, and then we get the real part of e to the it divided by d squared plus 2id minus 2 minus 2I plus 4. Note that here I multiplied I by I and got minus 1, but that minus 1 I brought it here and said 5 minus 1 to get 4. Okay, and that is multiplied by everything is multiplied by t. Okay, so we are looking for the real part again of, so we need to write this thing here in the form 1 over z plus 1, such that we will be able to apply the way we work out this thing here as being equals to 1 multiplied by 1 minus z, and then we then add z squared minus and so on. So we just need to make this thing in this form. Okay, so we're gonna have e to the it divided by so when let's our constant here. Oh, I missed a d here. I should have a d here, so please note this d here is like 2d, like we have d squared plus 2id minus 2d minus 2I plus 4. Okay, so our constant here is gonna be 2I plus 4. So let's factor out 2I plus 4. Okay, and then inside here we're gonna have d squared plus 2id minus 2d. Okay, and this is divided by 2. Okay, this 2 here is minus. Okay, minus 2I plus 4. Okay, and then plus 1. Okay, and then that is multiplied by t. Everything is multiplied by t. Okay, now going for note that we can write this as the real part of e to the it, I'm just rewriting by the way, divided by 4 minus 2i, and then this 4 minus 2i is multiplied by d squared plus 2id minus 2d divided by 4 minus 2i, okay, and then plus 1, okay. So everything is multiplied by t. Note that what we have here, like all of this bracket fraction here, is in this form, in the form 1 over z plus 1. So we can apply this rule here, okay. So we're gonna have the real part of e to the power of it divided by 4 minus 2i, right, and then we're gonna multiply that by 1 minus d squared plus 2id minus 2d divided by 2 multiplied by 2 minus I. Note that I just factored out 2 here, so to get 4 minus 2i, I just factored out 2, and then this thing is multiplied by t, okay. Okay, so let us multiply everything in the bracket here by t. So we're gonna get the real part of e to the it divided by 4 minus 2i of t, and then this t we subtract. When we take the derivative of t twice, we're gonna get 0. So the derivative of t once, we're gonna get according to this term, we're gonna get 2i, and then for this term we're gonna get minus 2, and then this is divided by 2 onto 2 minus I, okay. So you can see that this was a wise move, because I'm just gonna get rid of, like, this 2 gonna cancel this 2, and then this one. So in our numerator is given as okay, let me just copy out everything. I'm gonna need a new page for that. I need a new page. Okay, so let me just copy out everything. So that, okay, this, remember, this is yp is equals to the real part of e to the it divided by 2 into 2 minus I, and then this is multiplied by t minus I minus 1 over 2 minus I, okay. This is I, please. Okay, so we have that, okay. And then let us take the conjugate of this thing here, 2 minus I, in this part and in this part. So we're gonna get the real part of the conjugate of 2 minus I is gonna be 2 plus I e to the it, and that will be divided by 2 minus I, 2 plus I, okay, and that is multiplied by t minus I minus 1 multiplied by 2 plus I divided by 2 minus I, 2 plus I. Okay, so we want to determine this conjugate here. Okay, so that will be equals to the real part of 2 plus I b to the it divided by, when we work out this thing here, we're gonna get 4. We're gonna get 4, and then 5. We're gonna get 5 multiplied by 2, we're gonna get 10, and then that was multiplied by t minus. Okay, now let's work out this part here. We're gonna get 2. We're gonna get 2I, and then we're gonna get minus. Okay, let me just write it down. Okay, so we're gonna get 2I, and then I by I, you're gonna get minus 1, and then minus 2 here, and then minus 1 by I, you're gonna get minus I. Okay, and that is divided by 5. Okay, working this out, you're gonna get 5. So we have the real part of 2 plus I divided by 10 e to the it. Okay, and then this is t minus. Okay, so when we work this out here, we're gonna get 2I minus I. We're gonna get 2I minus I. We're gonna get I, so take the minus I, and then minus 1 minus 2, gonna get minus 3, which is plus 3 divided by 5. Okay, and we have that, and we want the real part of this. Okay, so going forth, what I'm gonna do, I'm just gonna multiply everything here, so we're gonna get the real part of simplifying this thing here, and then multiplying by t. I'm gonna simplifying and multiplying by t. I'm gonna get something like this. I'm gonna get 1 over 5 plus I over 10, and that is multiplied by e to the power of it, and also multiplied by t. So we're gonna multiply this by t. Okay, and then we subtract 2 plus I over 10, right, which is the same as this, and then we multiply it by it, multiply by I over 5, and then we're gonna get plus 3 over 5, 2 plus I divided by 10. Okay, my ear won't get here, so this e to the it gets here. Okay, and then we remember that we're still looking for the real part. This is a very long problem. Okay, so this is equal to the real part of 1 over 5 plus I over 10 multiplied by t multiplied by e to the power of it. Okay, multiplied by e to the power of it minus 1 over okay, let me put this minus 1 over 5 plus I over 10 e to the power of it multiplied by e my I over 5. Okay, everything here is multiplied by I over 5 plus 3 over 5 multiplied by 1 over 5 plus I over 10 e to the power of it. Okay, so when we are to write e to the power of it in terms of cos and sine, we're gonna get something like this, because I'm running out of time. So but if we had to do that, we're gonna get something like this. Okay, so we're gonna get t over 5. So this is, note that I'm not taking I'm not writing the real the re here, meaning that I'm only taking the real part. Okay, so t over 5 cos of t, okay, minus t over 10 sine of t plus sine of t divided by 25 plus cos of t divided by 50 plus 3 cos of t divided by 25, and then the last one, let me just write it here, minus 3 over 50 sine of t. Okay, note that we can simplify this further to write it in the form of sine of cos t. Okay, so we have cos of t, right? So with cos of t we have t over 5 and then plus 1 over 50, which is this one here, t over 5 here, 1 over 50 there, and then plus 3 over 25. Okay, so we let's add sine t. Okay, and with sine t we have 1 over 25, which is this time here, and then minus t over 10, which is this one here, and then minus 3 over 50, which is this term here. Okay, now when we are to simplify the what's inside the bracket, we're gonna get cos t into t over 5 plus 7 over 50 plus sine of t into minus t over 10 minus 1 over 50. Okay, this was a very long question. If you have a problem regarding the steps which I missed here, please let me know so that I can help you out with that one. But this is the actual work was actually covered, but the step which I left out, they are easy to do, because you're just gonna make e to the it, write e to the it in terms of like you're gonna write e to the it as being equals to cos of t plus I sine of t, and then from there you're just gonna multiply, because you're just gonna multiply out, and then you're gonna, after multiplying out, you're gonna take all the terms which do not contain I, and those terms will represent our real part. So that will be, you will be in this section taking those terms. So this is how you can do that problem. Okay, thank you for watching. Check out new videos on the operators and other sections of calculus math 2011. Thank you for watching. Enjoy.